we are looking at section 6.7, and then we are looking at integration by parts. Okay, in this episode, we are going to discuss when do we use it and what is the formula to solve integration by parts. And finally, we'll take a series of questions. Okay, actually, integration by parts is when you have products of two items. Okay, that is when we use integration by parts. Let's dive in quickly without wasting time. I'm going to start by generating the formula, and I will start with the product rule. ddx of two function uv is equal to v du dx, okay, then plus u dv dx. Then can we move this one the subject? Let's make this one the subject, and by solving we're going to have u dv dx equal to d dx of your product of two items, and then minus what? Minus v du dx. Then the next thing to do now, integrate the expression. Then we have u dv dx. Okay, integrate the expression, put your integral sign dx, then equal to d dx, put your integration sign of your products dx, which is the element of the integration, then minus integral of what? V du dx, and then put the dx. And this will now give us integral of u dv dx equal to, so this one will give us uv, and that's minus integral of v du dx. So that is the formula for integration. Okay, I'm going to go to questions now and break it down and see how we can use this expression. Okay, in a nutshell, this one will be your question. That will be your question given. Okay, so then the next thing to know, what is my u, what will be my u, what will be my v. So let's dive into examples. So look at this example now. So this is integrates these products. You have these two products, x times 1 plus x. So which one will be my u now? Use u is going to be what? You take u as well as this, because when the moment you do the u dx, this becomes similar on differentiation. So that's what? That's 1. Okay? Exactly now. Then look at your equation. We have dv dx. So which one is my dv dx? So the next item is my dv dx, which is what? Cos what? Cos x. Okay? And then from here, I need to what? I need to get v. I need to get v from here. And how do I do that? Very simple. Just integrate both sides. And that would be what? dv equal to what? Cos what? Cos x to what? Dx. So you can introduce your what? Integral sign. Then integral of the v is what? Is v. And the integral of this one is what? Is sin x. So we know our u now, and then we know our what? We know our v now. Then we can go straight and apply the formula. Okay? And don't forget, I've said this one is what? Is your question. Okay? So I'll just write the question, which is what? X cos x dx equal to uv, that's x sin x, then minus integral of what? My v is what? My v is sin x. Then I need the u dx. The u dx is what? Is 1. Then you put the element of the integration dx as simple as ABC. Okay? Then the next thing to now do now is to now do your final evaluation. This is what? This is this. And then integral of this one is minus cos x. So minus, that's what? That's plus cos x. And then plus c. And that's that on these applications of this formula. But you don't have to memorize it. Actually, most questions we make provisions for the formula. But you must know how to use it. You must know how to use it. And that's what we do in this episode.
to solve as many questions as possible, to break down the intricacy, to break down the rudiments of integration. Everything you need on integration on this module will be what we deliver to you. Question 2. Find integral of x squared ln x dx. That's the second example. So how do we solve this question? If you look at it now, you'll be looking at the question now is that what will be my u and what will be my v? That's the first question. So check the question. We don't have this one. We cannot integrate this. So we're going to take this one as u. So this one is what? This. And this one becomes what? It becomes simpler on what? On differentiation. So the u, the x dot of ln is what? Derivative of this one is 1 all over what? All over the function itself. That is how to differentiate ln function. Derivative of this, which is 1 all over the function itself. Okay, then the v, the x now. The v, the x is what? Will be this one, which is what? Which is x squared. So from here now, I need to get v. I need to extract a v from this place. So v is equal to what? V is equal to integral of what? X squared at dx, which is equal to, if you integrate this, that will what? Okay, so we've gotten u, we've gotten v now. So let's begin to plug in those values. So we now have now your question, which is this, equal to uv. My u is what? ln x. My v is what? S cubed over what? Over 3. Okay, then minus integral of what? My v is what? My v is s cubed over 3 times the u, the x, which is what? 1 over x. Then the x. So this will be equal to what? This. This 3 can come outside the integration. Then we have this, we cancel, we have x2 as dx. So finally, we have this one over this ln x, then minus 1 over 3. Integral of this is what? Is x cubed over what? Over 3, then plus what? Plus c. So we have this over 3 ln x, then minus s cubed over 3 times 3, that's 9 plus c. So that's that on that. So the next thing I want to do now is to begin to solve the exercise questions from this book. So if you are new on this channel, please click on the icon on this video and subscribe. Click on notification bell so that you can get notified anytime I upload a new video. Send your comments. Finally, share the links of this video on all your social media platforms. Thank you for doing that. So let's dive in now straight to what? Straight to the exercise questions. Okay, let's go there right away. Okay, and before we go there, let me tell you, please and please, this is not an entertainment. You need your writing material. You need your journal, you need your pen. So please take your pen there and follow along for what? For the exercise questions. Solution to the exercise question.